Hello, the purpose of this video is to explain some of the operation of a program counter for CPU as implemented in Logic World. This is my CPU here. It's a 4-bit CPU that is slowly being converted to a 5-bit CPU. As such, it needs a program counter. So let me explain the purpose and requirements of a program counter. A CPU executes instructions. The instructions in my case are stored in ROM. To be able to execute these instructions, I need a program counter that tells the CPU where the current instruction to be executed is. It's a fairly simple program counter. It has just a few requirements. Based on a clock signal that I provide in this clock sort of circuit here, it will increment the program counter. And it also, if there's a program counter write turned on 1, if this bit flag here goes to 1, it will write whatever's on the data bus to the program counter. This is just a display of the current value of the program counter. I'm going to set it to 0. This is just some manual stuff to make debugging easier. My program counter has 7 bits. In other words, it's counting up a 7-bit number from 0 until it gets to the end, and then it starts over. It wraps around. The 7 bits consist of a 5-bit address plus a 2-bit instruction step. The instruction step is needed because my control unit, which is this thing over here that executes instructions, breaks instructions up into multiple steps. That is just kind of the way some CPUs are implemented. That just makes things easier to use these sort of micro instructions or micro steps, depending on your definition, I guess. Okay, so that is the requirements and brief introduction of the program counter. I would say my program counter is kind of an awful example because it seems overly complicated. I found this sort of idea online and I was trying to implement it. But I will do my best to try to keep the explanation simple. The program counter has 3 levels here. The bottom level is keeps a register, the program counter register. That is just a place to store the current value of the program counter. So it in itself only does one thing, and that's remember the value of the program counter. The second level is my incrementer that allows me to increment the program counter. And the third is just a switch network that allows me to switch between incrementing with the clock or writing via writing a value to the program counter off the data bus when the program counter flag is this here is 1. Okay. So let me try to explain the basic operation here. The program counter is driven by a clock for the basic behavior of the program counter is to be able to increment it every time there's a clock pulse. This clock circuit is slightly complicated by the fact I can, sorry, I'm jumping around here. I could turn it on or off with this switch, and I can basically advance it by 1 tick. It uses a 1-tick pulse circuit, which is just this AND gate and this inverter. I have a video, I think, on how to do that. And it has a clock, which is just, I don't know why this thing is not smooth right now, sorry. But this clock has a delay and an inverter that feeds back into the delay, and that's it. Everything else on here is just the switches. So this clock feeds the clock pin of the program counter. Every time there's a clock pulse coming off of this clock circuit, it will send that to the write pin and will write the current value of the program counter. So for that to do anything, there needs to be a new higher value every time it gets around to writing. So that is accomplished by reading the value of the program counter at all times off this RD bus. This is my read direct bus. I do this on a number of my registers. This is always presenting whatever the value is of the program counter along this RD bus. So it's just constantly available. The RD bus is my address bus for my ROM. And so it sends the value of the program counter off this RD bus into the incrementer. The incrementer does one thing. It adds the value of that program counter plus 1. The 1 is provided by just this inverter. So this inverter is always 1, and that 1 goes into the low bit adder. This is a ripple adder, so it takes a little bit of time if there's a bunch of bits that have to carry. There's a bunch of, you could look at adder circuits online, and maybe I made a video or two about them. A faster solution would be to use what's called a look-ahead, carry look-ahead adder. So it takes the value of the program counter, it adds 1, and it sends it out these, kind of monstrosity of wiring lines to the top. The top is simply a switch. Normally it's set to just take what's on these pins off the ALU, the incrementer, and feed it back down through these PC in pins back to the inputs of the program counter, these PC6 in 5, 4, 3, 2, 1, 0 in. And so whenever the write goes off, it's already computed the next highest value until it hits that write. Till that write is true, it doesn't write that. And that write is exactly 1 pulse, so it doesn't get into a loop where it just keeps adding. So that's why the write is a 1-tick pulse. The clock itself is already a pulse, and it doesn't appear to need any delay, so I don't have one. The PC write signal for writing a new value to the program counter from the data bus actually goes through a 1-tick pulse circuit to make it a single pulse, and then into a delay. It just works out that way. And that's it. That's the program counter. I'm sure there are simpler ones. I could show you an operation. I will turn the clock on and it will start ticking up 1 step at a time. Every 4 steps, then the address 0 will change here. And then the program counter is connected to the ROM via the address bus. Yeah, here it is. This is the address bus coming into my ROM, switching demultiplexer circuits that are directing the signal to the proper address. I could show you this. I don't know why this is being like super glitchy because I'm recording, but it's not smooth. It's making it a little hard to smoothly show you what I want. Okay, but as you see, a bunch of those lines light up. So it's going here, then here, then here, then here, etc., running my program, which does very little. So it's not worth talking about. It's just mainly for debugging the CPU. Okay, I hope that was at all instructive. By all means, go forth and if you have learned something of this and do much better than I have done here, a cleaner, simpler program counter, and let me know about it. Thank you.